Okay, physics friends, another conservation of momentum example for you today. Today we're going to look at when two objects collide and they stick together. Okay, so this is also called an inelastic collision, when the two objects stick together after they run into one another. And so, for example, I have here a person on ice skates with a mass of 60 kilograms. They're headed to the right with an initial speed of 3 meters per second, and they're not really paying attention. They're going to run into this person of mass 70 kilograms that's moving to the left with a speed of -1 meter per second. Okay? And they run into each other, and then they end up sticking together, so they end up moving together as one object. And so I'm curious of what the final velocity is, so the speed and the direction, and how much energy was lost in that collision. Okay? So again, this is a conservation of momentum problem. So that tells me that the total momentum initially must equal the total momentum at the end, and I have to take into consideration the momentum of both objects. And remember that momentum is mass times velocity. Okay? So I have the mass of person 1 here times their initial velocity plus the mass of person 2 times their initial velocity. That's my total initial momentum because they're both moving. And I need to figure out the total final momentum. Well, they're moving together as one object this time. So that means I need to combine their masses, m1 plus m2, and then they move together with the same final velocity. And that's what I want. So putting in some numbers here, I have 60 times 3 plus 70 times -1. And yes, the negative matters, so make sure you include it. Okay? And then m1 plus m2, that's 130, and VF is what I'm interested in. Okay? So 60 times 3, that's 180, plus a -70 equals 130 VF. And so this would be 110 equals 130 times the final velocity, and divide by 130. So the final velocity of the two objects stuck together is 0.846 meters per second. Okay? What direction is it in? Are they going to move to the right, or are they going to move to the left? Well, with that case, I can look at the sign on this number, and I see that it's a positive value, which tells me that they're going to be moving to the right with how I have set up this problem. Okay. If you were to get a negative number here, then they would move to the left. Okay. Clearly they're not moving very fast after the collision. Okay. Now let's see how much energy was lost in that collision. So in that case, I'm going to look at my change in kinetic energy from the initial side to the final side. So I'm going to look at the total kinetic energy initially, and then I'm going to compare it to the total kinetic energy at the end. So I'm looking for a delta KE. Okay, so let's calculate the total kinetic energy initially. So that's going to be the kinetic energy of person 1 plus the kinetic energy of person 2, because they're both moving. So this would be 1/2 m1 v initial squared plus 1/2 m2 v initial squared. So that would be 1/2 60 times 3 squared plus 1/2 70 times -1 squared. Okay, so let's see, I haven't done this math yet, so let's take out our calculator. We have 0.5 times 60 times 3 squared. This is 270 joules plus 70 times 1 times 0.5. This is 35 joules. Okay. And that's my kinetic energy initial. So 270 plus 35 gives me 305. So the initial kinetic energy is 305 joules. Okay. But if I want the change in kinetic energy, that's KE final minus KE initial. So I also need the total final kinetic energy. So KE final, well, they're moving as one object, so I only have to take into consideration that one object. And so that's 1/2 mv final squared. And so that is 1/2 their combined mass of 130 times their final speed of 0.846 squared. So 0.846 squared times 130 divided by 2. I get a kinetic energy final of 46.5 joules. Okay. So my delta KE, or my change in kinetic energy, is going to be 46.5 joules minus 305 joules. Because remember, final minus initial. So 46.5 minus 305 tells me that 258.5 joules was lost in the collision. Okay. So that's another good example of checking for inelastic or elastic collisions, but this usually if it's inelastic, they normally say how much energy was lost. They don't normally ask if it was elastic, because if they stick together, it's not going to be elastic. Okay. Hope that helps.